So for removing, similar to adding, we have three options. We can either remove from the front, we can remove from the end, or we should be able to remove a node from the middle of our single linked list. So for our first example, we will look at removing from the front of the list. So if we have a node or an object at the front of our list, so for our single linked list, we will treat everything, I suppose, by position wise. So we have Mick in position 1, Bruce in position 2, Johnny in position 3, and Timmy in position 4. So if we wish to remove something, we'll specify which item we want to remove via a numeric parameter, i.e. an integer that we're going to pass to our remove method. So if we want to remove and we pass in 1, we're going to remove the first item. So how do we do this? So the logic involved with removing something from the first item will be to identify that it's in position 1. So once we're dealing with position 1, we're removing from the front of the list. So there's two things we'll need to change. First, we will need to identify the object which is going to be in the front position, and then we need to identify what's actually what's the next position. So once we've identified the object that's in position A or position 1, we have access to who's next in the list. So this object knows who's next. So the pointer that we have here, which is A at 0007, is the pointer to what's in position 2. Once we've removed the first object, the node that's in position 2 will be at the head of the list. So what we need to do is we need to update our list and copy our memory address from the front object and update the head pointer to point at the object in position that's currently in position 2. So what this has done for us is it has moved the head pointer to the Bruce object. At this stage then, the object that was at A at 0004 is no longer in our list. So when we actually iterate through our list, we always start at our head, and we'll go from the head pointer will point at the first item, which is now Bruce, and we can iterate through our single linked list. So Bruce points at Johnny, and Johnny points at Timmy. Timmy holds a null pointer to next, which is the end of our single linked list. So I suppose realistically this is a better representation of the current state of our single linked list.